All right. Good afternoon, everyone. My name is Ashley Predith. I'm a Senior Technical Advisor in the Office for Advanced Scientific Computing Research, or ASCR, in the DOE Office of Science. Welcome to our informational webinar on the funding opportunity announcement for advancements in artificial intelligence for science. Before we begin, we have a few logistics to cover. This meeting is being recorded. The recording and the slides will be posted this week on the ASCR Funding Opportunity webpage. There are closed captions available, and please click the closed caption button to enable them. After the presentation, there'll be a question and answer session. Please use the Q&A box in Zoom to ask your question. With that, we're going to turn to Dr. Hal Finkel, the Acting Division Director for ASCR Research Division, to start the presentation. Thanks.
Thanks, Ashley. Good afternoon or good morning, everyone. I'm going to provide an overview of our funding opportunity announcement, Advancements in Artificial Intelligence for Science. Before I start, I'd like to acknowledge that we have a whole team here who have worked on this funding opportunity announcement, and they will be working to answer your questions that you may put in the Q&A. Some of them will be able to address live afterwards in the Q&A session. And there are obviously details that we will not be able to cover in this presentation that are present in the opportunity announcement. I'm going to encourage everyone to look at the funding opportunity announcement itself in case you have any further questions, and you can feel free to reach out to us using the contact information present in the funding opportunity announcement if you have further questions. That having been said, I will start the presentation. We're going to have the presentation in a couple of different parts. The first part of the presentation will be a short overview of Advanced Scientific Computing Research, our ASCR program. Then we'll have an overview of the funding opportunity announcement, the research areas, and some other details. And then we will have a Q&A. So to begin, I will say that ASCR, the Advanced Scientific Computing Research Program, which is part of the Office of Science in the Department of Energy, has a long and rich history. We focus on fundamental advancements in computer science, in applied mathematics, and in computational science, in partnerships with computational science teams across the DOE, and we serve our entire mission space. We also have a part of ASCR that deploys some of the largest supercomputers in the world for open scientific research, as well as storage and networking infrastructure that enables large-scale, high-impact science for the nation. We are proud that our program has deployed the nation's first exascale supercomputer, Frontier. There are other exascale supercomputers, Aurora, being deployed as well, and other computational resources that serve DOE and the nation. The part of ASCR that has released this funding opportunity announcement is the research division. And the research division focuses on basic research in computer science and in applied mathematics, and also funds partnerships. The applied mathematics and computer science parts of the program, as well as the advanced computing technology part of the program, contribute to this funding opportunity announcement. And so we're seeking basic research in that context. I'm going to provide a very brief overview of some of the trends that are motivating our research program. These trends are in our mind as we construct our funding opportunity announcements, and will hopefully help to inform you about how our program sees its role and the changing technology ecosystem around us. First, I should say that a core part of our program is enabling advanced modeling and simulation and visualization of scientific phenomenon and the analysis of data from our scientific enterprise. The Department of Energy's mission and the Office of Science's mission is very broad, covering many different scientific domains. And the availability of computing has really revolutionized the way that we pursue science in all of those domains. As we know, there have been a lot of very exciting opportunities and results that have been generated in artificial intelligence, and the tools that are being made available to analyze large data sets, to extract insights from those data sets, are critical to the way that we intend to approach science in the future. In addition, our program has made important innovations in energy efficient computing and high performance computing, and we see that continuing into the future. The reality is that energy efficiency of computing is a core concern. We could not have reached exascale supercomputing without a key focus, a core focus on energy efficient computing and on energy efficient scalable algorithms. And as we move forward into the future, we are also grappling with increasing software complexity, which comes from the increased versatility, the precision of models, the overall accumulation of features and requirements on high precision, high consequence science. In order to deal with those, we have core investments in high performance computing, in edge computing, and in all of the scientific computational science computing that is needed across the enterprise in order to advance science in a number of different domain areas. And all of these trends, the advanced simulation, the AI, the big data, the energy efficient computing, the heterogeneous designs and the distributed nature of computing that go along with that, the increase in software complexity, as well as the very distributed and heterogeneous nature of where the computing is and the infrastructure needed to support it. All of those trends are impacting our program presently and are influencing the way that we are thinking about how we can support the scientific enterprise and our mission going forward. So this funding opportunity announcement, Advancements in Artificial Intelligence for Science, has been posted and is available publicly. We are looking for basic computer science and applied mathematics research in artificial intelligence for science. And this covers several main research areas: foundation models for computational science, automated scientific workflows in laboratories, scientific programming and scientific knowledge management systems, federated and privacy preserving training of foundation and other AI models for science, and energy efficient AI algorithms and hardware for science. I'll go through each of the 5 research areas in the solicitation in some detail, and then we'll talk about some other logistics. The first research area is extreme scale foundation models for computational science. And our program sees an opportunity to capitalize on recent advances in foundation model techniques, combined with the recently deployed exascale computing resources in order to jumpstart activities and research that will allow foundation models to be applied to computational science and significantly advance the state of the art of computational science across the board. Foundation models are trained on broad data. They generally use self-supervision for training and are applicable in a wide range of contexts. People have generally talked about foundation models, most commonly talked about foundation models in the context of large language models. And we also realize that there are other kinds of foundation models as well that can be key to science. And moreover, we are expecting that foundation models can be created in to consume multimodal data, and much scientific data is multimodal in nature. For the purpose of this research area, foundation models are expected to have at least tens of billions of parameters. Obviously, there are some foundation models that could be smaller, but in this context for this funding opportunity announcement, this research area focuses on the creation of larger foundation models. And it is expected that foundation models funded under this research area will explore innovative next generation capabilities, such as flexible multimodality, the advanced external integration of tools, or the integration of external tools, and sophisticated reasoning and planning, and robust memory techniques. Given the importance of accuracy and quantified uncertainty in science, research under this area must address how these factors will be addressed: accuracy and uncertainty quantification. And proposals must address how the training process or processes will minimize the risk associated with model misuse or unintentional biases or inaccuracy in model outputs, and other potential undesirable consequences. as I mentioned previously, our program deploys some of the largest supercomputers in the world for open scientific research. And we are proud that we have deployed exascale supercomputers, First Frontier, now Aurora. And these computers have tens of thousands of state-of-the-art GPUs and rank among the world's most powerful resources for computation and for AI model training. The proposed efforts under this research area are encouraged to make use of ASCR's exascale resources to create a foundation model or foundation models and take advantage of the extreme scale computing to advance the state of the art in foundation model creation. As a result, and for this research area only, a pre-application response to this funding opportunity announcement at the discretion of the applicant can include an articulation of likely high-performance computing resource requirements. And those requirements should be elaborated upon in a way that would be consistent with requirements that can be satisfied by the ASCR Leadership Computing Challenge program, the ALCC program. And there are specific requirements in the solicitation that detail what should be provided in this regard, so that we can evaluate that request. And should we encourage the pre-application, we will provide additional instructions on how to follow up with a specific request for resources. ASCR is seeking projects that will be ready to use HPC resources starting in 2024 on Frontier, Polaris, Promoter GPU, and/or Aurora. The second research area is AI innovations for scientific knowledge synthesis and software development. The state of the art in knowledge synthesis and programming tools are changing rapidly. And in part, this is fueled by large language models that are trained on text and source code and other data sources. Unfortunately, many of the new AI-driven tools are not trustworthy. They do not systematically understand mathematical or physical principles. They do not properly ingest and understand scientific literature and data, and they do not produce consistent, verified, uncertainty quantified, or reproducible results. So this research area seeks fundamental advancement in knowledge synthesis and programming tools for science, and realizing AI systems that can truly understand and assist with all aspects of the scientific process requires innovation in many areas. And these areas include multimodality and tool use, deeper reasoning and planning, and memory and external interaction. Additionally, investigations into AI tools for science should be conceptualized, accounting for the iterative and collaborative process that define modern science and scientific software development. Methods proposed for investigation should use any appropriate techniques to accomplish their goals. So that means that, of course, in this context, we are expecting AI, but any other aspects of machine learning, natural language processing, formal reasoning, instrumentation, data management, and compiler technology are also in scope for this research area. The third research area is AI innovations for computational decision support for complex systems. Scientific machine learning is a core component of artificial intelligence and computational technology that can be trained with scientific data or augment or automate human skills. Here we are focusing on outer loop applications of AI, and the term outer loop is increasingly used to describe computational applications that form an outer loop around forward simulation. So examples of outer loop applications can include optimization, uncertainty quantification, inverse problems, data assimilation, and control. In this research area, as with the other research areas, there are citations to reports that elaborate upon the areas and help define the terminology and the scope of advancements that are relevant. In this research area, for example, you should refer to Priority Research Direction number 6, Intelligent Automation of Decision Support. In the Basic Research Needs for Scientific Machine Learning, Core Technologies for Artificial Intelligence report to understand more about what's being sought in this area. Applicants must demonstrate that their proposed work is not specific to a particular complex system. It is expected that proposed projects will significantly benefit from the exploration of innovative ideas and the development of unconventional approaches. And proposed approaches may include innovative research with one or more key characteristics such as asynchronous computation, mixed precision arithmetic, automatic differentiation, concurrent sensing, and so on. There are additional details in the solicitation. The fourth research area is federated and privacy-preserving machine learning and synthetic data creation. The key challenge in training foundation models and other AI models for science are created by the reality that the data available for training is often sparse and distributed across different computing systems. Sometimes when there is too little data for training or the underlying data cannot be shared, more voluminous synthetic data can be created for AI training. Alternatively, there may be sufficient data, but it might be too voluminous to be transferred to a common system for training, or it might be restricted from being aggregated to protect privacy sensitivity or the proprietary nature of the data, thus requiring federated privacy-preserving AI training techniques. Another major challenge is the need for improved energy efficiency, scalability, and performance in federated training processes. So for this research area, the focus for federated learning is on the role and innovative use of federated approaches to train and fine-tune foundation models and other AI models for science on massive amounts of multimodal, distributed, and potentially privacy-sensitive data sets. Significant advances will be needed in asynchronous, randomized, and mixed precision and other algorithmic developments, optimization, numerical analyses that underpin the overall process of building and fine-tuning trustworthy foundation and other AI models for science. Additionally, challenges relevant to the creation and validation of foundation and other AI models for science might be addressed by innovative methods for the creation of synthetic data sets. And research may investigate the trade-offs between computation and communication, the storage of data versus the potential generation or regeneration of synthetic data. And finally, the fifth research area is the co-design of energy-efficient AI algorithms and hardware architectures. This research area seeks innovative approaches to energy-efficient scientific AI, including mathematical paradigms and modeling capabilities capable of predicting the resource efficiency of AI systems, potentially up to the largest scales. Energy-efficient AI technologies covering both training and inference, and including current technologies as a point of comparison, should be addressed holistically, accounting for the energy of parameter representations and model sizes, and other representational factors, plus computational energy for activations and other inherent operations in neural networks. Modeling capabilities to address energy efficiency should include both the ability to estimate resource usage relatively cheaply and the ability to perform detailed simulations of next-generation AI systems at extreme scales. It is important to note that in many respects, biological neurons are significantly more energy efficient than present-day computational approaches. And it has been long recognized that one factor that is likely key to this energy efficiency gap is the inherent use of sparsity and in connectivity and timing and so on, and that neurons in the brain are spiking. They transmit data asynchronously and sparsely on an as-needed basis in a limited neighborhood. This contrasts with the way that digital AI systems are generally constructed. And so this is specifically noted in this research area to encourage people to think about how those properties can impact future work on energy-efficient AI. Now, that having been said, the kinds of spiking neural networks just mentioned are not the only kind of AI approaches that are promising for significant increases in energy efficiency over modern AI systems. Hardware and algorithms, for example, neuromorphic algorithms utilizing statistical, probabilistic, approximate, subthreshold, photonic, cryogenic, and other hardware and software approaches remain the subject of significant and important investigations and are relevant for this research area. So those are the 5 research areas. There is a section in the solicitation on topics that are out of scope, and I'd like to discuss these in some detail. Of course, a proposal, a pre-application, or an application must address one of the 5 research areas that we just described. In addition, proposals and pre-proposals must address fundamental advances in AI for science. Our program, ASCR, is Advanced Scientific Computing Research, and our focus is on AI to enable science and scientific applications. It is very important that when you submit an application or a pre-application to this program, that you highlight specifically how what the work that you are proposing to do, what you're proposing to do, will impact science and scientific computing. Otherwise, your pre-application application would be out of scope. Moreover, you should describe the specific kinds of scientific computing workloads targeted by the investigations that you propose. If you do not do this, then your application will be out of scope. And moreover, you must provide a proposed set of activities, a proposed research area that generalizes to multiple applications. So if you provide a pre-application or an application that is discipline specific or application specific and does not generalize to multiple kinds of applications, multiple kinds of scientific applications, then your pre-application or application will be out of scope. Additionally, we are not supporting in this solicitation applications or approaches for quantum computers. There are several different ways that we support having multiple institutions collaborate on a single project in response to this solicitation. The ways that we have to support this are two different structural mechanisms. One is collaborative applications, and the other is subawards. You should refer to the solicitation for the particular details. Briefly, collaborative applications are where multiple institutions each separately submit a proposal to the solicitation, whereas subawards are proposed subcontracts, and a lead institution submits a proposal proposing to subcontract to another. Whether you use subcontracts or whether you are using collaborative applications, there is a limit on the amount of money that can be requested for an entire team. $2,350,000 per year. There are specific ceilings and floors that also apply to each institution's application being submitted. And these are listed here on the slide. So the ceiling for DOE National Laboratories is $2 million per year. The ceiling for all other applicants is $350,000 per year. We are expecting approximately 6 to 8 awards in total. As I said, there are additional details that are in the solicitation, and you should consult the solicitation when ensuring that the work that you're proposing and the teaming structure that you propose meet the requirements for the solicitation. I will also note briefly that while DOE National Laboratories and other federal agencies and other federal agencies, FFRDCs, can be proposed as subrecipients, they may not be proposed as subrecipients if they could otherwise propose as a collaborative institution. So if they are requesting funding that would be in addition, that would exceed the floor for that kind of institution, they must be proposed as collaborative using the collaborative proposal mechanism. Finally, in order to apply for this solicitation, you have to submit a pre-application. The pre-applications are due on March 19th at 5 p.m. Eastern Time. The pre-application, as stated, is required. The details of the pre-application and the submission procedure are in the funding opportunity announcement. I will note quickly just a couple of things. One is that the first page of the pre-application must specify a scientific hypothesis whose investigation motivates the proposed work. There are specific requirements for how that should be presented in the pre-application, and those requirements are in the solicitation. It is very important to note that we are a basic science funding program, and it is essential that you have a scientific hypothesis that your proposed work is investigating. If you propose only to develop a tool or the like, then, and there is no scientific hypothesis being investigated, then you will not meet the basic requirements for submitting to this solicitation. Your pre-application should also include a listing of senior and key personnel and the listing of individuals who should not serve as merit reviewers on the subsequent application, on the subsequent proposal. This list must be included as an additional attachment when you submit your pre-application in PAMS. And there is an Excel template that is provided, and we prefer that you use that template. Feedback about pre-applications can be provided upon request after award selections have been announced. Okay, so that is the conclusion of the presentation on the funding solicitation. So I'm going to hand this back over to Ashley now, and we can start the Q&A. And also thank my colleagues ahead of time. We have a whole team here who are working to answer your questions. Thank you.
Thank you, Hal. We've been having a robust number of questions here in the Q&A. So if you haven't taken a look at that, I'd suggest going over there and taking a look there. Let's see here what's coming up. Can you talk about how many years will these projects run?
3 years.
3 years. Okay. And should the proposal be limited to one research area, or can it encompass multiple areas?
The proposal should primarily address one area.
We're going to continue to monitor the chat for broadly applicable questions here. Could you emphasize the out of scope science part again? The slide that covers that.
Sure. So at its core, our program funds advancements in scientific computing research. And it is essential that proposals address some key scientific questions in computer science or applied mathematics for artificial intelligence that have a articulated nexus with science, computational science. Our program invests in order to advance the scientific mission of the Department of Energy, and it is important that the work that you propose have a particular proposed impact on scientific computing, on science that is relevant to our mission.
Thank you. Does research area 5 fund the co-design of algorithm with hardware systems using emergent devices?
Yes, work along those lines may be in scope.
Okay. What application areas are good for validating proposed work? Might you want to have someone comment on SC use cases?
So I encourage folks who are not familiar with the Office of Science and its mission to visit the Office of Science webpage and look at the scientific areas that are covered by the various programs. The Office of Science has a, frankly, huge mission space, covering everything from nuclear physics and high energy physics through biological and climate sciences and material science. There's a huge space of potential application areas in science to all of these techniques. Some of them I just mentioned, there are many others.
Thank you. If a proposal addresses key questions in AI and computing, can the project also propose to develop a tool for a scientific application?
Our basic science funding research is for investigating questions in computer science and applied mathematics. We do care about the quality of the artifacts that are generated by the science that we fund. In part, this enables us to most effectively have the scientific community build upon successes from our scientific mission funding.
Could you repeat the teaming institution criteria once more, please? It read as the call was restricted only to FFRDC's primary collaborative, but not to universities.
No, it's not restricted to FFRDCs. Universities are eligible to apply.
Thank you. All right. With respect to the point about a scientific hypothesis on the first page, does that refer to a hard science or to an applied math CS hypothesis?
That replies to a hypothesis relative to applied mathematics or computer science. Or the advanced computing technologies being investigated.
Can patent pending AI explainability and compliance with physics work be included in the proposal?
I think for that kind of question, it's best if you could send us a question in writing.
How does the neuromorphic research area in the SFOA different from the neuromorphic research area in other DOE FOAs, such as the Express one?
So the neuromorphic research area in Express, for instance, is specifically looking for neuromorphic computing technologies that are inspired by biological systems. The topic area here is more generally focused on energy efficient computing technologies.
Thank you. Is this funding call primarily or solely targeting researchers in the computer science and applied math fields, or would domain experts working on developing foundation models for particular scientific fields like HEP or ASTRO have a likelihood of success if they can figure out ways to generalize their foundation models beyond their particular fields?
If the work being proposed generalizes to multiple fields and advances the state of the art in the mathematics or computer science of AI, then it can be in scope for this solicitation.
What should be the main difference between this DOE opportunity proposal versus NSF's proposal targeting foundations of AI and machine learning?
So I can't comment specifically on the scope of the NSF solicitation. Our solicitation is focused on meeting the needs of our program and our mission within DOE and the Office of Science.
While Research One has resources available, will there be any opportunities to use DOE resources for the other research areas? For number 2, training models for software development could be resource intensive, and in research area 5, access to emerging AI hardware would be very helpful. Are there any plans there?
We have a variety of different allocation programs that are available from ASCR, and I encourage you to look at the spectrum of programs and allocation programs that are available. If you have any further questions, you should feel free to reach out.
Thank you. For research area 1, if the applicant chooses to submit ALCC allocation, is the allocation guaranteed? Will it be starting next year in June of 25, or will it start in October of 24? What is the impact of ALCC rating with the main funding opportunity announcement rating? Will the sum of both ratings be considered for the funding decision?
So both ALCC and this solicitation are being managed by the ASCR program, and the decisions will be synchronized programmatically. We are looking for proposals that will be ready to begin work soon. in 2024, and we will provide specific instructions on any additional information that needs to be submitted for the ALCC proposal with the pre-application response.
Are projects proposing to develop tools discouraged, even if the research identifies and focuses on hypotheses in computing as well?
The development of tools is not discouraged. We, as I said, care deeply about the quality of the artifacts that are produced by the research that we fund. And we hope that successful research can be built upon by the scientific community and for our mission. But there must be a primary focus on investigating a core interesting question in computer science or applied mathematics for AI.
Mm-hmm. Does research area 5 include research in hardware, software, algorithm, co-design itself, or is it focused on the modeling that can predict the performance and efficiency in such co-designs?
Can you repeat the question?
Yeah. Does research area 5 include research in hardware, software, algorithm, co-design itself, or is it focused on the modeling that can predict the performance and efficiency of such co-designs?
I think it's probably best if we receive that question in writing.
Yeah.
I have at least two different ways I can interpret that, and I think it's probably going to be helpful if we can clarify that in a more concrete fashion.
Any expected perspective on addressing computational resources needed for the program? What hardware is the focus of research area 5? Is that GPUs and HPC only, or also some other edge devices with programmable architecture like FPGA?
Yeah, that's a good question. So our focus is on advanced scientific computing. Obviously, there is a lot of advanced scientific computing that happens in the data center on HPC resources with GPUs. We have just deployed exascale machines and are looking forward to future advanced architectures. That having been said, there is also a lot of very important advanced scientific computing that happens at the edge and in other locations outside of perhaps large data centers. And all of that computing can be instrumental to the mission of the Office of Science and the scientific enterprise.
How about development of numerical algorithms that replace expensive components of computation with machine learning approaches? Do they fit in area 2 or in any other area?
So this is a question about the development of surrogate models for particular applications.
Those numerical algorithms that replace expensive components of computation with machine learning approaches.
Yes, it's a good question about where this would fit best in general. Do any of my colleagues have thoughts on this question?
Depends on the use of the surrogate. So research area 3, complex decision support. It's one potential. We have to look at the details.
Yeah, I tend to agree. I think this is a question that may be better addressed as a follow-up. It probably does depend on the use of the surrogate as to whether that work will be in scope at all for the work for the solicitation, and if so, where it fits.
Thank you. For research area 5, can the proposal be solely focused on software techniques for measurement, modeling, and tuning at the algorithm and/or system software domain at the HPC compute center level without necessarily having hardware co-design thrust?
Yes, I think hardware co-design is not specifically required in that topic.
Is there a recommended cost model, for example, how much money per GPU per hour to use when estimating compute costs on the mentioned clusters, for example, Aurora?
No, we do not provide a cost model. If that's relevant, then the applicant should propose a cost model, and the details of that model can be part of the merit review.
Can you elaborate on the hypothesis-driven item in the out-of-scope description? Advancing machine learning typically develops a useful tool instead of a concrete scientific hypothesis, so I'm confused.
So we fund scientific research, and for work in computer science or applied mathematics, while people often think about it as though they're going to make a tool, we require that the investigation be motivated by a hypothesis. Generally, if you're going to make a tool, you do have some hypothesis about what you're doing and what's going to happen, and you can articulate why that will be an interesting question to investigate.
Does the research area 5 include the development of AI for the design of energy efficient hardware? Does research area 5 accept making improvements in SNNs as shown by simulation, or it should be shown in a hardware or neuromorphic implementation?
Robinson, would you like to address that question?
Can you repeat the question? I was answering some questions.
Sure, yep. Does research area 5 include the development of AI for the design of energy efficient hardware? Does research number 5 accept making improvements in SNNs as shown by simulation, or should it be shown in a hardware or neuromorphic implementation?
The answer is yes. The overall topic is general AI, so it can accommodate most AI approaches. For neuromorphic computing, I would say that it does need to have a neuroscience-based justification for the approach.
Thank you. This looks like the focus of this FOA is AI advances, so perhaps the project needs to be led by AI researchers, but those advances are meant to be for multiple scientific applications, so perhaps in collaboration with domain experts. Is it necessary to have multiple domain experts on the team?
So we don't impose any particular requirements for team composition, and we do not have any particular requirements for the background of the PI. But I will say that the strength of the team will be evaluated as part of the merit review. So you should put together the team that will be most competitive for the work you're proposing, and that will be evaluated as part of the review process.
Thank you. If neuromorphic computing methodologies across device, circuit, architecture, algorithm levels, is it fit the topic? If neuromorphic computing methodologies across device, circuit, architecture, algorithm levels, does it fit the topic?
From a hardware point of view, it does, but I will still reinforce the neuroscience-based justification for the approach.
Thank you. For research area 2, when developing AI-driven tools for scientific knowledge discovery, is the focus of the scientific hypothesis mainly on CS and applied math or downstream scientific use cases?
The hypothesis should refer to a computer science or applied mathematics hypothesis that's being investigated by the proposed research. The research, if it's successful, should have impact on multiple scientific domains. And of course, the investigations in those domains will have their own hypotheses in those domains. But for this solicitation, for the proposal itself in response to this solicitation, there should be a computer science or applied mathematics hypothesis that is motivating the proposed work.
All research area 1 has resources available. Will there be any opportunities to use DOE resources for the other research areas? For research area 2, training models for software development could be resource intensive, and research area 5, access to emerging AI hardware would be helpful. Are there any plans there?
So we have a variety of different allocation programs and resources that are available. For research area 1, we have a specific provision that we have provided for an application for resources, but there are allocation programs that are available across our facilities. And we also have AI test beds that are available. And I encourage you to look at the ASCR User Facility webpage to understand more about those resources that are available. If you have any further questions, then please feel free to follow up.
For research area 1, high performance computing by its nature tends to be domain specific. Will proposals heavily investing in one specific domain area be discouraged?
Work has to be applicable to multiple scientific domain areas.
And the proposal include the purchase of small test beds or novel hardware to accomplish the research goals?
It just answer it on text.
Yeah, and if you have further questions on allowable costs, you can feel free to reach out.
Will it be considered out of scope of research area 5 to explore beyond CMOS emerging technologies for energy efficient AI computational hardware?
No, beyond CMOS approaches are in scope for that research area.
Can you elaborate a bit about research area 4? It encompasses many areas from synthetic data creation, federated learning, privacy preserving. Does it need to address all of them or a subset?
Work proposed for research area 4 does not need to address all of those different areas. It should address the basic challenge of being able to train foundation models and other AI models for science with data that is distributed and is potentially sensitive for privacy or other reasons. Steve, is there anything else you want to add to that?
Correct. Thank you, Al. The question also asked about what is the selection ratio for the pre-proposal, and we don't have a specific selection ratio in mind, but we want to invite and encourage things that are in scope and that are competitive.
Is it possible to have a team led by domain experts with sufficient machine learning experience as opposed to computer science expert?
Yes, you should compose your team in the way that you feel is most competitive.
Do we need to demonstrate generalizability of AI methods developed in multiple application domains, or is it sufficient to demonstrate in one application area and explain how the solution is applicable to across domains?
I just answered that in text.
Okay, thank you.
Bill, I think this is actually an important question. Do you want to also repeat the answer?
Sure. What I said is that a single application with an explanation for other application areas is acceptable, but that multiple applications would probably be better.
Is there any preference regarding large-scale projects over $2 million per year or medium or smaller scale projects?
We do not have a particular preference. And I expect that there will be an entire spectrum of project sizes from which we will be choosing when we make selections.
Are there proposals that synergize with other labs and funding opportunity announcements from BES or FES welcome, especially if the synergy provides a method by which we can validate our applied math CS scientific hypothesis?
So we are looking for the work that we fund to impact the scientific work that is core to the programs within the Office of Science. It is important that the work proposed stands alone in the sense that it should not depend on funding from other offices or other projects in a way that is not explained as a risk. And ideally does not have those kinds of dependencies, but synergies are important to understand, and highlighting them is encouraged.
For high performance computing, can the PI budget for third-party resources like cloud computing from the private sector, or have it use DOE's facilities? Is DOE's high performance computing free to use, or does it incur a fee schedule for the PI?
So there are a variety of different allocation programs, and I encourage you to look at their specific requirements. If you are planning to use cloud resources, you can budget for those. If you have specific questions on allowable costs, then I recommend you follow up by email. Generally speaking, for non-proprietary use, our user facilities and other resources are free to use, but they are granted on a competitive basis, and a separate application proposal is needed.
Thank you. For topic 5, whether SNN is the primary focus or other novel brain-inspired methods like hyperdimensional computing will be considered equivalently, can you define scientific computing?
Okay. So there are a couple parts to that question. One is that we are open to considering many different kinds of innovative approaches to energy efficient AI. We do specifically call out spiking neural networks and neuromorphic computing, and we do have a specific interest in those techniques, but other proposed techniques will be considered on an equivalent basis. Scientific computing is going to be computing that has a specific impact on or nexus to our scientific enterprise and the scientific mission of the agency.
Thank you. For research area 3, does fast and efficient surrogate modeling that encompasses multiple scientific domains satisfy the requirements, or does it need to explicitly focus on outer loop applications such as inverse modeling or optimization?
Bill, want to take that?
So the surrogates enable efficient computation of the outer loops, but you need to make that connection in the proposal or pre-proposal.
We have about 5 minutes left, so I think we're probably going to take about 2 more questions here before we wrap up. For area 2, is the focus mainly on scientific knowledge discovery or software development, or both?
It could be either or both.
In terms of research area 5, does the AI algorithm optimization and CMOS-based ASIC accelerator co-design fit the program?
Yeah, that could be in scope for that area.
Thank you. All right. We've taken our 2 more questions. Let's see here. We are going to put back in the chat here the where the recording and the slides are going to be available. So let me just pop that in there for everyone. And we want to thank everyone for joining today's webinar. There are a lot of questions, a lot of interest in this. So thank you so much for coming. If you have any follow-up questions, please consult the funding opportunity announcement and contact the relevant program manager listed there. Thanks, everyone, and we look forward to what comes out. Goodbye.